Understanding external voltage regulator bypass requires knowing the evolution of charging systems in Dodge, Chrysler, and Jeep vehicles. Before 2005, most Dodge, Chrysler, and Jeep vehicles used external voltage regulators that operated independently from the engine control module. These external regulators were separate components, typically mounted on the firewall or fender well, providing simple mechanical control of the alternator output. Modern vehicles after 2005 integrated charging system management directly into the engine control module or powertrain control module. These modern systems monitor battery voltage, temperature, and electrical load to optimize alternator output for maximum efficiency and battery life. This diagram shows a typical modern ECM-controlled charging system with the powertrain control module managing alternator output through integrated circuits and sensors. External voltage regulator bypass is primarily used in three scenarios: older vehicles with original external systems, racing applications where simplified electrical systems are preferred, and when ECM charging control has failed. This wiring diagram shows a typical external voltage regulator setup with connections for battery, ignition, and field control, demonstrating the simpler architecture compared to ECM integrated systems. The bypass offers benefits like simplified electrical systems and reduced failure points, especially valuable for off-road applications and classic car restorations. However, important considerations include potential warranty implications, emissions compliance issues, and the loss of smart charging features that optimize battery life and fuel efficiency. As modern vehicles become increasingly complex with integrated electrical systems, external regulator bypass becomes more specialized, primarily serving performance, off-road, and restoration applications rather than general automotive use. Before beginning any electrical work, safety must be the top priority. The first critical step is to disconnect the battery's negative terminal to prevent electrical shorts and potential injury. Next, locate the alternator's field terminals. These are typically labeled F1 and F2, or simply FLD. You'll also need to identify other key terminals for proper wiring. Disconnect the ECM control wire from the alternator. This wire typically connects to the field terminal and allows the engine control module to regulate charging. We'll replace this with our external regulator. Mount the external voltage regulator in a suitable location, typically on the firewall or fender well. Now we'll make the 4 essential connections for proper operation. Proper grounding is critical for reliable operation. Use the chassis ground connection diagram as a reference. Ensure clean metal-to-metal contact and use appropriate hardware, including tooth washers and lock nuts. Several critical safety considerations must be addressed. Ensure proper amperage ratings for all connections to prevent overheating. The ECM may generate error codes when it no longer controls the charging system, and improper wiring can cause electrical fires or damage expensive components. Professional installation is strongly recommended for vehicles with complex ECM integration. After installation, comprehensive testing must be performed to verify proper voltage regulation and system operation. Document all modifications for future reference and maintenance.